There is a quiet machine floating above your head right now. You cannot hear it working. You cannot see it moving. It does not hum like a generator or glow like a solar panel. Most people pass through their entire lives without realizing that it exists, yet every moment of every day it is storing water, more water than every river flowing across the continents. The strange part is that this machine costs almost nothing to build. No electricity, no batteries, no fuel, just a few dollars in simple materials and the invisible moisture drifting through the air around. If you stepped outside tonight and stretched the simple sheet between two poles, the sky itself would begin filling a container with clean drinking water while you slept. By sunrise, droplets would slide down the surface and collect quietly below, water that never passed through pipes or pumps or treatment plants, water that appeared almost out of nowhere. For thousands of years, people have known this secret. Farmers on dry mountainsides, desert travelers crossing empty dunes, and remote villages surrounded by fog all discovered that the air itself carries water waiting to be gathered. But somewhere along the way, that simple knowledge faded from public view. And today, a device that can pull drinking water straight out of thin air for just a few dollars has quietly become one of the most uncomfortable ideas in the modern world. Because once people realize the sky is already full of water, a lot of powerful industries suddenly start to look very different. And if you're here listening to this right now, it probably means you feel that same curiosity I felt the first time I stumbled across this story. If that curiosity pulls you in the same way it pulled me in, you might consider staying for the journey, maybe even subscribing so we can keep uncovering things like this together. Not because it helps the channel grow, but because conversations like this are how forgotten knowledge survives. The strange story of pulling water from the air really begins in one of the harshest environments on Earth. In the early 1900s, a German naturalist crossed the vast desert landscape along the western edge of South America. The Atacama Desert stretched in every direction around him, a place so dry that rain had not fallen in some regions for decades. Scientists believed almost nothing could survive there without a constant water source. But one morning, just after sunrise, he noticed something curious moving across the sand. A small black beetle climbed to the crest of a dune and stopped. Instead of searching for plants or burrowing beneath the sand, it tilted its body upward toward the ocean wind, drifting inland. That wind carried a faint mist from the Pacific, invisible droplets suspended in the air. As the fog moved across the beetle's shell, tiny bumps on its back began collecting those droplets. One by one, they merged into small beads of water. The curved shape of the shell guided each droplet downward until the hairs gathered near the insect's mouth. In a place where rainfall was almost non-existent, the beetle was drinking water harvested directly from the air. The naturalist sketched the shell carefully in his notebook. The pattern of ridges and grooves fascinated him. Each tiny bump worked like a miniature condensation surface, capturing microscopic moisture from the passing fog. Later, he experimented with a simple idea inspired by what he saw. He stretched a piece of fine mesh between two poles and placed a container beneath it. When fog drifted through the mesh overnight, droplets began forming along the threads. By morning, they had combined into larger drops that ran downward into the container. Fresh water, collected silently from the air. What fascinated him even more was how simple the process was. No pumps, no engines, just wind, temperature differences, and gravity. Many decades later, researchers noticed something similar happening along the coastal mountains of Chile. Villages perched high above the ocean often sat directly inside slow-moving fog banks that rolled inland each morning. Local fishermen began stretching large nets between wooden poles along the hillsides. The fog flowed through the mesh like waves through a fishing net, but the moisture stayed behind. Thousands of tiny threads trapped droplets from the air until gravity pulled them downward into metal gutters placed along the bottom edge. Some of these nets produced hundreds of liters of water each day, enough to supply entire communities that previously relied on distant wells or unpredictable rivers. And what I find especially remarkable about that story is how ordinary the materials were. Wooden poles, fabric mesh, simple pipes or containers to collect the water. Nothing about the system required complicated technology. Just patience and an understanding of how the air behaves. If you're listening right now and this idea is starting to click in your mind the way it did in mine, you might already be imagining how something like this could work where you live. And honestly, moments like that are the reason I enjoy making these videos. If this story sparks that kind of thinking for you, leaving a like or sharing your thoughts in the comments actually helps. More people stumble across knowledge like this, not for algorithms, just for curiosity. In the early 1990s, a Canadian nonprofit organization called FogQuest began installing large fog collectors in rural parts of Peru. Many farming communities there lived in landscapes where rainfall was scarce, but coastal fog passed through regularly. Before the collectors were installed, families often walked long distances each day to gather water from muddy streams. Children carried heavy containers along dusty roads before school. Some communities had to choose between using their limited water for drinking or for growing crops. The fog collectors changed that almost overnight. Rows of tall mesh panels appeared along the ridges above the villages. Each morning, fog drifted through the panels, leaving thousands of droplets clinging to the threads. Those droplets ran into pipes that delivered clean water directly into storage tanks. Suddenly, there was enough water not only for drinking, but for gardens, livestock, and small orchards. Children who once spent hours fetching water were free to attend school. Small farms began growing vegetables where only dry soil had existed before. The transformation was quiet but profound. Similar systems eventually appeared in parts of Morocco, Eritrea, and Guatemala. Each region adapted the design slightly, depending on the climate, but the principle remained exactly the same. Moist air meets a surface, droplets form, gravity does the rest. What surprised researchers was how efficient these systems could become. In the right conditions, a single fog net could produce hundreds of liters of water per day. And the cost of building one was far lower than drilling wells or installing large pumping systems. In other words, a simple structure made from inexpensive materials could provide a steady water supply in places where traditional infrastructure was almost impossible. Around the same time, scientists studying atmospheric moisture began measuring just how much water exists in the air surrounding our planet. The numbers were almost difficult to believe. The atmosphere holds roughly 12,900 cubic kilometers of water vapor at any given time. That is more fresh water suspended in the air than all the rivers on Earth combined. Even in dry regions, the air still contains moisture. A cubic meter of air at relatively low humidity can hold several grams of water vapor. That might not sound like much until you consider the enormous volume of air constantly moving across landscapes every day. Researchers realized that capturing even a tiny fraction of that moisture could provide significant amounts of water. Laboratories around the world began experimenting with new materials designed specifically to absorb atmospheric moisture. Some use specialized crystals called metal organic frameworks that attract water molecules like magnets. Others tested gel-based films capable of soaking up humidity during the night and releasing it when warmed by sunlight. One experimental system built in the desert was able to produce about a liter of drinking water each day using nothing more than sunlight and dry desert air. Another design developed in a university lab used a simple gel film that cost only a few dollars in raw materials. In controlled tests, it produced several liters of water daily. But what fascinated me the most during my research was something much simpler than any laboratory invention: condensation. The same process you see every morning when dew forms on grass or when moisture appears on a cold glass of water. At night, certain surfaces cool faster than the surrounding air. When warm, humid air touches those cooler surfaces, the moisture condenses into droplets. That is exactly why tents often appear damp at sunrise. Your camping tarp is already acting like a water collector without you even trying. Once you understand that simple piece of physics, building a basic atmospheric water collector becomes surprisingly easy. Stretch a tarp or sheet at a slight angle between two trees. Place a clean container at the lowest corner. During the night, the surface cools as it radiates heat toward the open sky. Moisture in the surrounding air condenses on the surface and flows downward into the container. In humid environments, this setup can collect several liters by morning. Another approach uses mesh panels, similar to the fog collectors used in mountain regions. Window screen mesh stretched between poles works surprisingly well, as fog or humid air passes through the mesh. Droplets gather along the fibers until they merge and drip downward. Attach a small gutter beneath the mesh, and the water flows directly into a container. No electricity, but no pumps, just air, temperature, and gravity working together. There are even experiments using thin gel coatings made from common ingredients that absorb moisture overnight and release it when warmed by sunlight the next day. Spread the mixture on a plastic sheet, allow it to dry, and it begins behaving almost like a sponge for humidity. Placed at a slight angle above a container, the captured moisture eventually condenses and drips downward. What amazes me most about all of this is how quietly the sky provides water all the time. You can see the evidence every morning. On leaves, on rooftops, on car windshields, and on blades of grass covered with dew. The atmosphere never stopped offering that water. We simply stopped noticing it, and maybe that's why stories like this matter to me personally. Every now and then, you stumble across a piece of knowledge that reminds you how many simple solutions already exist around us. If this kind of story resonates with you, if it makes you pause and think about the world a little differently, then I'm really glad you're here listening. Truly, sometimes leaving a comment or subscribing isn't about supporting a channel. Sometimes it's just a way of saying, yeah, keep sharing things like this, because the more people remember these quiet ideas, the harder they are to forget again. And the next time you step outside early in the morning and see dew shining in the first light of the sun, you might notice something different. Not just moisture, but proof that the air itself has been offering water